Use IDs to solve. All right, here we go. Here's your first example, guys. I'm going to give you what's given, and then I'm going to tell you what we have to find. So for example 1, I'll just put given over here on the left, and what we need to find over here on the right. So what is given is cotangent of x, and cotangent of x is 2 over 5 square root 5. And then we're given sine x, and sine x is going to be root 5 over 3. And what we are looking for is cosine. Okay, so for the main part in this chapter, the angle measurements of x, we don't even care what the angles are. We don't care about the degrees. We don't care about the radians. We are just focusing on the ratios. So if we are given cotangent and sine, and we're trying to find cosine, remember cotangent is a quotient property. Cotangent is one of your quotient IDs, which is cosine x over sine x. So I am able to fill in 2 pieces of info here. So I am going to use this quotient property. Guys, I'm just building an equation and solving for what I'm looking for. That's all it is. Cotangent of x, over here on the left side, I'm going to input what I know cotangent of x is. It's given to us. So this is 2 over 5 square root 5. I'm going to copy the equal sign. And remember, we do not know cosine x, but we do know sine x. So I'm going to write square root 5 over 3 here. Whoops. And then, guys, this equation, you would solve just like the one in orange. You're just going to multiply both sides by the denominator, and you'll solve. So the denominator over here is going to be root 5 over 3. We're going to multiply both sides by root 5 over 3. All right. So these are going to cancel. So cosine of x is going to equal 5 times root 2 on the top. I'm sorry, square root 5 times 2 on the top. On the bottom, this is 3 times 5 square root 5. So the bottom is going to be 15 square root 5. And guys, those square roots cancel out. So cosine of x is going to be 2/15. I'll just write that right here, 2/15. And that's using your trig ID to solve. What I would like to point out is notice you have 2 known values here. And then we went straight to a quotient property to proceed with that. That's going to change on the next example, because on the next example you only have 1 value. So let's take a look at example 2. So for example 2, I'm just going to make a chart again of what's given and what we need to find. All right, here's what's given. We know that sine beta equals 1/6. We know sine beta equals 1/6. We also know cosine beta is greater than 0. Here's what we got to find, guys. We have to find cotangent beta. And we also need to find secant beta. All right, let's talk about what's given. So what's given is 2 pieces of info, but cosine beta is greater than 0. What does that tell you? That just tells you the sign. What numbers are greater than 0? Yeah, that's all it tells us. So we just know this is positive. We have no idea what the value is. So what you have is just one unknown, or I'm sorry, one known. When you have just one known, you're always going to use that over there. It's always a Pythagorean identity. One known, always use, and I'll just abbreviate, Pythagorean identity. And you got to be able to choose which one that you have values in. I'm given sine, so I'm going to use the main one. Sine squared plus cosine squared equals 1. Sine squared beta plus cosine squared beta equals 1. We're going to plug in what we know and then solve for what we don't. We know what sine is. We know the sine value is 1/6. So I'm going to drop that in right here and then square it. So sine is 1/6. I'm going to square that in a moment. I have no idea what cosine is, so that stays. So essentially, guys, what we're doing, we're going to square this and then move it to the other side and square root it. Let's go ahead and square this. Square the top and the bottom. That is 1/36 plus cosine squared beta equals 1. Y'all, when I move this 1/36 to here, I'm going to have to combine it with that whole number. So I'm just going to rewrite the whole number as a common denominator. So cosine squared beta, here's my whole number 1. Watch how I write the number 1. And then I'm going to do minus 1/36. All right, so we're about to square root 35/36. Now remember, usually when we square root something, we do plus and minus. But we already know cosine is positive, so I'm just going to square root it and leave it positive. I'm going to square root the top and the bottom. So cosine beta is going to be the square root of 35. There's no perfects in that. Oops, that's off my screen. There's no perfects in that. Over the square root of 36, but the square root of 36 is perfect. So cosine beta is the square root of 35/6. So as you guys can see, I have several lines in my work, and that's not even the answer. I'm looking for cotangent and secant. I can find secant pretty quickly because I can flip that upside down. So let's go ahead and find secant. I'll just write it right here. Secant beta is going to equal this upside down, 6 over the square root of 35. And that is absolutely what secant equals, but it's ugly. Don't forget, you have to rationalize every denominator. So secant beta in its pretty form is going to be 6 square root 35/35. Nothing simplifies. All right, now let's find cotangent. Remember, to find cotangent, it's cosine over sine. We have cosine right here. We have sine right here, so we're just going to go ahead and do that division. So cotangent of beta is going to be cosine, which is the square root of 35/6, divided by sine, which is 1/6. And guys, y'all know how to divide fractions. You multiply by the reciprocal. So this is going to be the square root of 35/6 times the reciprocal of the bottom fraction. So that's going to be 6/1. And then, guys, those 6's cancel out. So cotangent is going to be the square root of 35/1, but we're not writing it over 1. So cotangent beta is just the square root of 35. And I'm just going to write that at the top of my paper because I have a blank part.